Today, let's see the topic Unit 1 Nature of Physical World and Measurement. In this unit, we see the topic 1.4 Measurement. What is measurement? So, the comparison of any physical quantity with its standard unit is known as measurement. The next topic, definition of physical quantity. Quantities that can be measured and in terms of which laws of physics are described are called physical quantities. Examples are length, mass, time, force, energy, etc. Then, types of physical quantities. Physical quantities are classified into two types. They are fundamental and derived quantities. What is fundamental quantity? Fundamental or base quantities are quantities which cannot be expressed in terms of any other physical quantities. The examples are length, mass, time, electric current, temperature, luminous intensity, and amount of substance. And what is derived quantity? Quantities that can be expressed in terms of fundamental quantities are called derived quantities. Example, area, volume, velocity, acceleration, force, etc. Let's see the next topic, definition of unit and its types. What is unit? An arbitrarily chosen standard of measurement of a quantity which is accepted internationally is called unit of the quantity. There are two types of units. One is fundamental unit and another one is derived unit. The units in which the fundamental quantities are measured are called fundamental or base units, and the units of measurement of all other physical quantities which can be obtained by a suitable multiplication or division of powers of fundamental units are called derived units. Next topic, different types of measurement systems. A complete set of units which is used to measure all kinds of fundamental and derived quantities is called a system of units. There are three system is given here. Let's see one by one. First one, the Fps system. The Fps system is the British engineering system of units which uses foot, pound and second as the three basic units for measuring length, mass and time respectively. For measuring length, the unit foot is used. For measuring mass, the unit pound is used, and for time, second is used. Then the next system is CGS system. The CGS system is the Gaussian system which uses centimeter, gram and second as the three basic units for measuring length, mass and time respectively. The third system is MKS system. The MKS system is based on meter, kilogram and second as the three basic units for measuring length, mass and time respectively. Do you know the CGS, MKS and SI are metric or decimal system of units? The FBS system is not a metric system. Next topic, let's see the next topic, SI unit system. The system of units used by scientists and engineers around the world is commonly called the metric system, but since 1960 it has been known officially as the International System or SI. The SI, with a standard scheme of symbols, units and abbreviations, were developed and recommended by the General Conference on Weights and Measures in 1971 for international usage in scientific, technical, industrial, and commercial work. The advantages of the SI system are, which is very important for the examination point of view. So the advantages of SI system are: first one, the system makes use of only one unit for one physical quantity, which means a rational system of units. In this system, all the derived units can be easily obtained from basic and supplementary units, which means it is a coherent system of units. Then third one, it is a metric system, which means that multiples and submultiples can be expressed as powers of 10. There are 7 fundamental units as given in the table. Let's see one by one. First one, base quantity, length, unit meter, symbol small m. So the definition of meter is 1 meter is the length of the path traveled by light in vacuum in 1 divided by 299,792,458 of a second. Next, quantity mass, unit kilogram, symbol kg. 1 kilogram is the mass of the prototype cylinder of platinum iridium alloy preserved at the International Bureau of Weights and Measures at Serves near Paris, France. Next quantity, fundamental quantity, time, its unit second, symbol S. 1 second is the duration of 9,192,631,770 periods of radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atom. Next, fundamental quantity, electric current, unit ampere, symbol capital A. 1 ampere is the constant current which, when maintained in each of the two straight parallel conductors of infinite length and negligible cross section held 1 meter apart in vacuum, shall produce a force per unit length of 2 into 10 power minus 7 Newton per meter between them. The next fundamental quantity, temperature, its unit Kelvin, symbol K. 1 Kelvin is the fraction of 1 divided by 273.6 of the thermodynamic temperature of the triple point of the water. Next fundamental quantity, amount of substance, its unit is mole, symbol small letter MOL. 1 mole is the amount of substance which contains as many elementary entities as there are atoms in 0.012 kg of pure carbon 12. The last fundamental quantity, luminous intensity, its unit is cantilla, symbol CD. 1 cantilla is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 5.4 into 10 power 14 hertz, and that has a radiant intensity of 1 divided by 683 watt per steradian in that direction. Then what is tribble point? Tribble point of a water is the temperature at which saturated vapor, pure and melting ice are all in equilibrium. The triple point temperature of water is 273.16 Kelvin. Thank you.